Well, hello, and welcome to this third part in my series on transformation by shear and stretch. Now, this is in two parts. Is from an actual exam question, an iGCSE maths. We said for the IB and for O level, I think, as well. Now, we've been asked to displace this shaded region here by shear transformation, and the clue is that they want the point 0,2 there to move from 0,2 to 3,2 there. So that's our first start, and then we now have to move from this point here, 0,2 to 2,2. That move from there to there. Now for this region, for this length here, now that will now move from this point to that point there. And of course, all the points on the invariant line do not change. So in effect, they remain the same. So now our new square now becomes the parallelogram. And of course, the area will be the same. Well, check it out and see. So the area of this square here should be the same as the area of the parallelogram. Right, now the displacement is going to be either from the point 0,2 to 3,2 or from the point 2,2 to 5,2. Now the displacement is parallel to the x-axis and it's always the same. So in this case it's 3. Now the distance from the invariant line there to any given point is 2. In this case, from the point in question is 2. And from there to there is 2. So in effect, B to A is 2. Now, in order to calculate our shear factor, we divide the displacement by the value of the y coordinate from the invariant line to the point in question. In this case, we're looking at the line of y is equal to 2, and the line of y is equal to 2 is there. Okay, so from B to A is 2. So now our shear factor is now 3/2, which is 1.5. Now to test this, we say that the transformation matrix is 1, 0, and 1.5. Well, 1.5 because 3/2 is 1.5. Now if you multiply that by the coordinates there, and that's what you get. So now if we multiply 1 times 2, we get 2. 1.5 times 2, we get 3. So the new x coordinate value is going to be 5. And the new y coordinate value is going to be 0 times 2 is 0, and 1 times 2 is 2. So 0 plus 2 is 2. So now we've got the point. So the point 2,2 now becomes the point 5,2 because 2 plus 3 is 5, and 0 plus 2 is 2. So it's 5,2. Similarly, the point 0,2, which is there, now becomes the point 3,2. Now, hope that makes sense. Now, for the stretch, on the next slide. Well, hello again. In the last slide, we looked at transformation by shear. Now, here we are going to look at transformation by stretch. And we are asked to move from the point 0,2 there to the point 0,6. And what we do is we draw the rectangle as shown coming up here. So it would be nice for you to check the area of this new rectangle compared to the area of the old square, or the old rectangle if you want to. Okay, right. Now we measure from the invariant line to the top of the rectangle, in this case 6. And we also measure from B to A. Now B to A is the old value of y. So in effect, it's there. So y, the old value for y is 2. And the new value for y is 6 from the invariant line. So our stretch factor then becomes, if you divide the new value of y by the old value of y, in this case divide 6 by 2, we have a stretch factor of 3. So what we're actually doing is, if we say we've got a previous unit matrix of 1, because if you say from 0 to 2 is 1 unit matrix, so from 0 to 6 now becomes 3 unit matrix, hence 3 there. Right. To check if you're right, if we multiply the transformation matrix here by the individual coordinate point, so we're looking at the point at 0, 2 and the point at 2, 2. Right. Now, if we multiply 1 by 0, which is 0, plus 0 times 2, and that will give us 0, because 0 times 2 is 0. So 0 plus 0 is 0. So the x coordinate of 0, 2 after transformation by stretch is still 0. Now, if we then multiply 0 times 0 and 3 times 2, we get 6. So we get 0 plus 6 is 6. So the new coordinate of the transformed point there is now 6. So we end up with 0, 6 for 0, 2. We end up with 0, 6 for 0, 2 and 2, 6 for 2, 2. So 2, 6 will be there, 2 and 6. Now, I hope all that made sense, and thank you for watching. Please subscribe and let us know how you feel about this. Thank you. Bye-bye now.